Hey everyone, welcome to today's lesson. Today we are going to basically just be practicing more of the vertex form. So you remember we are able to identify the vertex, obviously, whether the function opens up or down, and what kind of slope pattern is represented in the a value, and that helps us graph the parabola. We're also going to focus on describing the transformation from the parent parabola y equals x squared. So with that said, I just have one example for you and then like 3 practice problems. This shouldn't take a very long time, but your goal today is, like I said, to be able to graph a parabola from vertex form. And later on, we're going to be talking about other forms like standard form and factored form and how to graph parabolas from those two forms as well, because all different forms give different information to help us graph in different ways. So with that said, go ahead and take notes on this. Remember, notes are on the right-hand side, examples on the right-hand side, and then practice problems are going to be on the left-hand side. Remember, vertex form is y equals a times x minus h squared plus k. And to be able to graph a parabola effectively, you're going to be looking for 3 things. The first thing you're going to look for is whether the parabola, the function, opens up or down. And we tell that by the sign of the a value. So if a is positive or negative. If a is positive, then the function opens up. And if a is negative, then the function opens down. Okay, so the second thing that we look for, and then to describe that, that is a reflection about the x-axis. You'll see an example of that in a little while. The second thing we look for is the slope pattern. So you remember the standard slope pattern is 1 over 1, 4 over 2, 9 over 3. It's a result of perfect squares. Well, that also comes from the a value. So depending on the numeric value of a, that will help us identify the slope pattern, okay? And we call that a vertical stretch or a vertical shrink, depending on whether a is greater than 1 or less than 1. And the third thing we look for is the vertex. Now, usually it's the first thing we look for because that's where we start our graph. But when describing what's happening, it's the last thing we describe. So remember, the vertex is actually the h and the k values, here, where we change the sign of whatever we see inside the parentheses for h, and we keep the sign for whatever we see in the for the value of k. So hk is our vertex, and we describe that as a translation or a shift of some sort. So with that said, let's go ahead and take a look at an example of this. I want you to do 3 things. I want you to describe the transformation, I want you to graph the function, and then I want you to identify the domain and the range of the function. Okay, so with that said, let's go ahead and take a look at y equals negative 1/2 x plus 6 squared plus 9. So let me write that down here. Y equals negative 1/2 times x plus 6 squared plus 9. Remember 3 things. We're looking for, number 1, which way the parabola opens. We can see that the a value is negative, therefore the parabola is going to open down. We want to describe this transformation, so we're going to describe it this way. We're going to say the parent function, and we want to tell everybody what the parent function is. Y equals x squared is, well, what is it? It's reflected about the x-axis. Okay, so that basically tells me that the parabola is going to open downward instead of upward. Okay, so that's the first thing we look for. I'll put a comma there because there's more to it. The next thing we look for is a vertical stretch or shrink. Since we see in this particular problem that the a value is less than 1, or I should say between 0 and 1, we would say that there's a vertical shrink. So we would say vertically shrunk by a factor of 1/2, whatever the a value is the factor, okay? And then the last thing we look for is the vertex or the translation. So we would say shifted or translated. So we say and translated 6 units left. Why left? Because remember, we changed the sign of what we see for the h value. So 6 units left and 9 units up. So we don't change the sign on the outside value. Okay, so that's describing the transformation. That's part A. Part B is to graph the function. So I'm going to actually do that. So let's see. Do I have room? I don't really have much room, so I'll do it underneath. We're going to graph that function. Well, the first thing we want to do, and we kind of already did that already, is identify the vertex. Okay, so I'm going to just put it in very basic terms instead of a big long sentence. We want to describe it using good vocabulary, but we're going to just quickly write down the vertex, which is -6, 9. And we know that it opens down. And then when we look at our slope pattern, remember our slope pattern or our graphing pattern starts with 1 over 1, 4 over 2, and 9 over 3. That's the beginning of it. These are perfect squares. But remember, what do we do with all these? We multiply the numerator by the a value. So I'm going to convert that to decimal form just to make it a little bit easier to see. So I'm going to multiply this by 0.5, multiply this by 0.5, multiply this by 0.5. If you want, you can think of it as multiplying by 0.5 over 1. Okay? And so what is 1 times 0.5? Well, it's 0.5. 1 times 1 is 1. So there's my new slope pattern there. 4 times 0.5 is 2. 2 times 1 is 2. 9 times 0.5 is 4.5. And 3 times 1 is 3. So there we have the 3 things that we need to graph this parabola effectively. So I'm going to go ahead and draw an XY plane here and plot what I know. Well, the vertex is -6, 9. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh boy, I blew that up. Let's see here. Let me move my axis of symmetry. I just don't want any of the writing to get in the way of my graph. So let me move my axis of symmetry maybe further this way so I can graph it more effectively. Okay, so we're going to go back 6. 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to put our vertex. There's our points. From there, we're going to follow the slope pattern. So we're going to go down 1/2 over 1. From the vertex again, we're going to follow the next step, which is down 2 over 2. Then the next one from the vertex is down 4.5. 1, 2, 3, 4.5 over 3. And then since I have so much room on my graph, I'm going to keep going with this slope pattern. So we got 9 over 3. The next one will be 16 over 4. We'll multiply that by 0.5 because the a value is 0.5. So half of 16 is 8. So we got 8 over 4 here. So it'll be down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. And we'll keep going because we got a little bit more room. The next one will be 25 over 5. Multiply that by 0.5, which is 12.5 over 5. So down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5 over 1, 2, 3, 4, 5. So there we have as many points as we need here. And then we'll reflect all those points across the axis of symmetry to get the other side of the parabola. And so we can see our parabola taking shape. Okay. All right. Well, not working very well on this side here. All right. So there is my parabola. There's my description. There's my parabola. And the last thing it wanted was the domain and the range. So let's see here. I'm going to go ahead and write that right here. The domain is the set of x values. So how far back do we go here? We actually go back to -infinity. And how far to the right do we go? We go to +infinity. Because these arrows are here, it keeps going further and further out both ways. So the domain is -infinity to infinity. And then the range is, well, the lowest point is going to be -infinity. And when I say -infinity here, it doesn't necessarily mean -infinity there. Negative infinity in the x direction means to the left, where negative infinity in the y direction means down. So we go down negative infinity. How far up do we go? Well, we go up to our highest vertex point, which is the 9. So we'd say less than y less than or equal to 9, because the parabola does actually touch the value of 9. All right, so that is your example. That should be on the right-hand side of your notes. This is a good example of what's expected on a test in terms of descriptions, identifying key points, and graphing, okay? Let's go ahead and do a couple practice problems here. So you should probably turn it over to the left-hand side so that you can do these. Same concepts here. So go ahead and pause the video and see if you can do this on your own before you watch the rest of this. So for number 1, it gives us the equation y equals -3 times x minus 1 squared minus 10. So the first thing we're going to say is the parent function of y equals x squared is, well, it's got a negative a value, so it's reflected about the x-axis. Okay, we've got that. Then it is vertically stretched this time, not shrunk, stretched by a factor of 3. Okay, so that since that's bigger than 1, it's a stretch, not a shrink. And then we would say translated 1 unit right and 10 units down. So there is our description of our transformation. That's part A. Part B, we got to graph it, so let's identify the vertex first. The vertex is +1, -10. Remember, change the sign, keep the sign. And then we have a parabola that opens down. And our slope pattern is going to be multiplied by -3. So we would say, let's see, 1 over 1, 4 over 2, 9 over 3, and we'll multiply that by 3 on each of those. So we're not going to be able to fit very many in this graph. So our new slope pattern is going to be 3 over 1, 12 over 2, 27 over 3. Okay, and we'll go ahead and graph this guy based on what we see here. So our vertex is 1, -10, so 2, 4, 6, 8, 10. We got 1 point right there. All right, move the camera there. And then we know that it opens, we know that it opens down. So this parabola is going to actually be going downward. I forgot to multiply by -3 here. So it's going to be down 3, down 12, down 27. So this graph is going to be actually way off in the negative direction. So from the vertex, we're going to go down 3 over 1. And then from the vertex, we're going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm out of room. So we're just going to go with that 1 point. We'll reflect that. And that's kind of the best that we can do for that problem. Okay. You can see that it's getting vertically stretched. We're taking the points. If I were to plot this normally, it would have been here for the normal slope pattern. We're stretching it vertically. We're pulling it down. And so it becomes stretched out. Well, inevitably, when it becomes stretched out, it becomes skinnier looking. And that's what we have here, okay? So that's number 1. And then our domain, let's go ahead and answer that. Our domain is, again, going to be -infinity to infinity. And our range, in this case, is going to be -infinity up to -10. Okay? Notice I put a bracket here. That's the same as saying -infinity less than y less than or equal to -10. That bracket implies equals. The parenthesis implies not equal. Okay? So let's go ahead and do number 2. we have for number 2, we have y equals 1/2 x plus 4 squared minus 2. So if we're going to describe this, we don't have a reflection because the a value is not negative. So we don't even have to state that. The next thing we look for is a vertical stretch or shrink. We would say the parent function y equals x squared is vertically shrunk, because that's less than 1, by a factor of 1/2, and then it is and it's translated 4 units left and 2 units down. So there's our description. That's part A. Part B, graph. So we would say the vertex is going to be -4, -2. We know that it opens up in this case, opens up, and our slope pattern of 1, 1, 4, 2, and 9, 3 are all going to be multiplied by 0.5 because that's our a value. So we would end up with 0.5 over 1, 2 over 2, 4.5 over 3. And so we can graph that pretty easily now. Let's see, -4, -2, opening up. Let's see here. So we have our xy plane. -4, -2 means back 4, down 2. So there's our vertex. Following that slope pattern, we're going to go up 1/2 over 1. From the vertex again, up 2 over 2. From the vertex, up 4.5 over 3. The next one, because I can keep going, 16 over 4 times 0.5 becomes 8 over 4. So 2, 4, 6, 8 over 4. And then we could keep going. 25 over 5 times 0.5 gives you 12.5 over 5. So 2, 4, 6, 8, 10, 12.5 over 5. Okay. Then we'll reflect it on the other side. Oops. Kind of went into my work there. I'm just going to do my best job of connecting those. So you can see that we have a parabola. Okay. And for part C, we are to identify the domain. The domain is, again, -infinity to infinity. And the range, well, in this case, the lowest point is -2, less than or equal to y, and the highest point is infinity. Okay, so that's a little bit different look at that. All right, so that is number 2 example. Hopefully you have a good idea of graphing these things and describing them. Let's do one more problem, and let's see what you can do with this. I got a little trick here for you. Let's see if you catch it. Okay, so go ahead and pause and see if you can come up with an answer here. All right. Did you catch it? I know some of you are thinking, well, that 2/3, that makes it really hard. And yeah, it could. But there's something else that's kind of key here. Did you notice? There's no squared. There's no squared. Oh, Mr. Bernier must have just screwed up. He's supposed to put the squared there because that's what we're doing. We're doing parabolas. It must be. No. We want to be able to compare between things that we've known in the past to things that we're learning now. So this isn't a parabola. That was intentional. What kind of function is this? This is a line. This is a linear function, right? Now I can convert this to slope-intercept form just fine, but I want to keep it simple, or I want to keep going along the pattern of what we've been doing so that you can see the connection here. Okay, so let's go ahead and describe this relationship. Well, first of all, in our description, we would say the parent function. Well, what's the parent function this time? It's not y equals x squared because this isn't a parabola. The parent function is y equals x. That is the parent function of a line, right? Y equals X is what? Well, we see the negative, so we'd say it's reflected about the x-axis, okay? And we would say that it is vertically shrunk by a factor of 2/3. That's basically your slope. And then we would say it's translated 6 units left and 4 units up. All right, so there's the description. Notice the difference is that the parent function is y equals x, right? But everything else is the same. Now, when we go to graph this, we know that this isn't a parabola, so there is no vertex, okay? But there is a point. The point that I start with would be just like when I start with a vertex. The point that I start with is going to be -6, 4. Change this sign, keep that sign, okay? The next thing is, well, does it open up or open down? It's not really a matter of opening up or opening down because it's not a parabola, it's a line. So what can we answer in regards to this negative here? It doesn't open down, it has a negative slope. In other words, the function is going to be decreasing. So let me go and write that down. It's decreasing. And then when we talk about the slope pattern, it's not that there's a slope pattern. There's a pattern there, but it's a constant slope. The slope stays the same for every point along the way. So it's not a matter of changing the slope like we would a parabola. The slope just remains -2/3. That's the slope, okay? And so when we go to graph this guy, we're going to start at -6, -6, +4. So I got my xy plane. -6, +4, we're going to go back 6 and up 4 and put a point. And then we're going to follow the slope of -2/3. So down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. And we have our line. The reason it's a line is because the exponent, the highest exponent here is a 1, not a 2. And so we can graph this line like we would a parabola, identifying your key point, identifying your slope pattern, and then just going with it along the way, okay? The last thing, I guess we could talk about domain and range. I'll do that in a second. But before we do that, I want to look at the equation itself so that you can see that it's actually exactly what you would have expected it to be. If I convert this into slope-intercept form, well, the way I would do that is to distribute the -2/3 in. So I end up with -2/3 x. Well, what's -2/3 times 6? Let me do that work off to the side here. -2/3 times 6, remember that's 6 over 1. So -2 times 6 is -12. 3 times 1 is 3, and that reduces to -4. And so when I distribute that, the -2/3 times the 6, I end up with -4. And then we have this +4 hanging out here. And then I can simplify this by combining like terms. I got -2/3 x, and then you could put +0 there if you want. There's your slope-intercept form. And look at that. The y-intercept is 0. Oh, the y-intercept is 0. And it has a slope of -2/3. So whether it's in slope-intercept form or in this general form, is what we would refer to this as, you can still graph it. So getting used to this is actually going to make you graph lines a lot faster. All right, and then the last thing, the domain and the range. Well, the domain in this guy is going to be all real numbers, -infinity to infinity, because it goes to the left forever and it goes to the right forever. And then the range is going to be also -infinity to infinity, because the graph goes down forever and it goes up forever, right? The lowest point is -infinity, the highest point is +infinity. All right, that wraps up this lesson. Hopefully you have a good, a better grasp of graphing parabolas from Vertex Form and describing their transformations from the parent function. If you have any questions, please comment below. And if you found this video helpful, go ahead and hit like. I noticed some of you are putting dislike. Yes, I know, I see. Anyways, I'll talk to you guys all later.